Hello viewers, this is Sanmitra and in this video I am going to teach you how to find the equivalent capacitance between these two terminals A and B for such an arrangement of parallel plates. This is a very common configuration and many of you know what is the answer. The answer is if I give you the area of the plates as A and the distance as say D and this is also D, then you can find the distance capacitor equivalent. You will find in many books, that is 3 epsilon naught A by D, that is the 3 line parallel. But actually many students find it very difficult to visualize how this is happening, how this is parallel. So I'm going to teach you how to visualize it, and if for given any configuration, if any configuration is given, then how to reduce it into simple configuration, so that how to reduce it into a simple configuration which you are used to, not like this, and then you will be able to solve it. Okay, let's do it. And now see one more thing. If I change the distance, the D and 2D, then how will you do? So these things, first of all, let me remove this D. See here, let us number the plates which are facing each other. And let's take the top plate. This is not facing any plate, so I'm not numbering this. I'm starting from this one. This as number 1. I'm showing in red. This is number 1. This is number 2. This is number 3. This is 4. This is 5. This is 6, and this is not facing any other plate. So I'm numbering the plates at first. Now what I'll do here is that here, let me draw terminal A this side. Let me draw terminal A here, and let me draw terminal B here. This, first of all, this plate 1, it is connected to terminal B. This plate 1 is connected to terminal B. So I will be drawing a plate and I will name it as 1, and it is connected to B. Also plate 4 and 5, they are also connected to B. So 4 also and 5 also I will be drawing, and I will be connecting it to B. Now from A, what are connected? 2 is connected from A, and one more thing we have to see, 2 is facing 1, that is opposite to 1. So I will be drawing 2 just opposite to 1. This is important. This is important actually, because this 2 forms the capacitance pair, capacitor pair. So this will be connected to A. 3 is connected to 4, and 3 is also connected to A. So I will be drawing 3 opposite to 4. At first let's draw what is facing the other ones. See, 6 is facing 5. So 6 also I will be drawing opposite. Now what I will do is that I will connect, see, 3 is connected to A and 6 is also connected to A. So like this also 6 I will connect to A. So like this I am reducing this arrangement, which looks somewhat complicated, into a simple arrangement like this. Now it is very simple. Now the distance is D for all the capacitors and the area is A. Now we can find out capacitance is, equivalent capacitance is 3 times, because all are in parallel, epsilon naught A by D. Actually this analysis is important, because what if I change the question? Like, what if I change the question? I am adding a dielectric here. This is K. Now how will we approach this question? Now I already know that this will come out like this. Okay, I am removing this also. Now that is why the understanding is important. It is not that I will be remembering the results and plugging the formula. That is not the way how we should learn physics. See, this is, I will be only numbering those plates which are facing each other. This is K, and let me take one thing. Let this be 2D. This is D, and let that be 2D. Now the complication comes. We cannot do this problem just by mugging up. Say D and 2D. This is 1, this is 2, this is 3, this is 4, this is 5, this is 6. Okay. Now let's draw the plate 1. It is connected to B. This is 1. Opposite to 1 is 2. B also 3 is connected to B, and 5 is also connected to B. Opposite to 3 is 4. Opposite to 5 is 6. So this is my configuration. This is A and this is B. Now, between 3 and 4, there is a dielectric. This distance is D, this distance is D, and between 3 and 4, the distance is 2D. So, what is C12? C12 is simply epsilon naught A by D. What is C34? C34 will be this K, dielectric constant is K. K epsilon naught A by 2D. And what is C56? Epsilon naught A by D. Now, what is the equivalent capacitance? CAB. Just add them. Epsilon naught A by D will be common. 1 plus K by 2 plus 1. So 2 plus K by 2 into epsilon naught A by D. So this is how we will approach these kind of problems. Let me show you one more configuration, then it will be crystal clear. Let's take the same number of plates. I'll be connecting the top and the bottom plates and the middle plates. And now this I'm connecting to A and this I'll be connecting to B. Now tell me how to reduce this into a simple circuit. First of all, can you just do it by looking at it? Very difficult. Very difficult. Let's number those plates which are facing each other. This plate is say 1, this is 2, this is 3, this is 4, this is 5, and this one is 6. 1, 2, 3, 4, 5, 6. Now, from A, which plates are connected? A is 1 and 6. 1 and 6 are connected from A. Opposite to 1 is 2. Opposite to 6 is 5. So this one capacitor pair is formed. These are connected to B. Also from B, there are two more. See, there is one more pair, there is 3 and 4, which are itself connected to B. That means both the plates, say this is 3 and this is 4, both are connected to the same terminal B. Now, what will happen if I apply a voltage source here? This is a short circuit. This pair is a non-existent, this is a redundant thing. Not redundant, this is actually not a capacitance pair because both terminals are shorted. See, this is not a capacitor. So, we have only two here. This 6, 5 and this is 1, 2. Now, if I give you the values, this is A, then the distance between them is D. So, I can easily find out C equivalent is 2 epsilon naught A by D. That means both are 2 are in parallel. Okay. Now if I change the values, they're like one in case of 1D I'm writing 2D. So if I write here 2D, then it will be A, and if I change the, say I put a dielectric here. So this kind of modifications the examiner can do, and if the examiner does this kind of modifications, then I think you will be able to handle it, because I have shown you the exact method how to analyze the things and reduce it into simple solvable circuit. So if you like my channel, then please subscribe to my channel and click on the bell icon. Thank you.